So today I'll be walking you through the eye of real-time graph plotting. Wow, this is interesting. For the first time, I'll be plotting directly, in your graph book. So it's going to be an interesting one. And in this particular graph I'm about to plot is in respect to the job that a client, a student sent from Bayes University in Abuja, Nigeria. Okay, so let us see this particular graph. There are three of them I'll be plotting, but this first one is based on the principle of measurement of focal length of convex and concave lens. The theoretical equation for which you are going to see showing on the screen.
And then the other, from what I'm saying,
1 over f equal to 1 over li minus or plus 1 over lo equal to 2 over radius of curvature, capital R. So the experiment has been carried out and values have been obtained, all right? So this particular value is for convex lens measurement, while this one focuses on concave lens measurement. I've chosen my axis. The students were required to plot a graph of Li times Lo against Li plus Lo. Li plus Lo. The unit of this is centimeter, and the unit of this is square centimeter. Square centimeter. You can see that, right? Because you are multiplying two length parameters. Now from the table of value, we are plotting this column against this column. Looking at the values we have here, I had to select my axis. And you can see the axis here. This is the vertical axis, Li times Lo axis. And of course, this is the horizontal axis. You can see that. This is the horizontal axis, Li plus Lo axis. Now, I chose the axis this way. You can see from the marginal line, I only left a 2 centimeter line. Then I moved up. I didn't leave, much space here. And then look at the vertical axis, the Li times Lo axis. You notice that I did not even leave any unique centimeter space here. The reason is very simple. All right. We do not have negative values in the column to be plotted. No negative value. You can see that. All the values we have here are positive values. All right. So on the basis of that, we decide to select our axis, the vertical and the horizontal. At those points, I selected them. Remember, if we had negative values in this table, which we do not have, but suppose we had, it would have affected where I place the vertical and the horizontal. So I want to bear that in mind. Okay. So now I'm going to do a fun class on placement of axis. All right. Now that I've chosen my axis, that is where to place my Li times Lo and where to place my Li plus Lo, the vertical and the horizontal axis respectively. You see the origin here marked as 0, 0. Before selecting my scale, all I have to do is to determine the number of lines available for plot. I had said this in previous video where I, treated the concept of graph plotting. So let us see the number of lines available for plots along the vertical, okay? This graph is already standardized into 2 centimeter. This horizontal line is our 0 line already. So this is our first line available for plot. 2, 3, 4, 5, 6, 7, and 8. I usually like leaving at least 2 centimeter free space. So I'm going to stop here, the 8 line. I'm going to stop here. All right, which means if I'm plotting my graph, plus minus, my graph shouldn't go beyond this. If for any reason it goes beyond this line along the vertical, then this space that I left will help to cover it up. That is why I usually leave up to 2 centimeter free space. Are you following right? In counting the number of lines available for plot. Now I have known how many lines that are available for plot along the vertical, because the horizontal lines, see all these horizontal lines, right? They pile up to give you a vertical. They pile up to give you what? A vertical height. And that forms our vertical. In this case, the column Li times Lo. Since I have 8 lines available for plot, this can now help me to select my scale. So I want to select my scale. To select my scale, all I have to do is to look at my Li times Lo column of the table and then ask myself, what is the highest value there? The highest value here is 187.5. So I'm going to press 187.5. Then I'll divide it by the number of lines available for plot. 187 divided by 8 lines available for plot on the vertical axis. Then we'll find out that this is 23.375. What the calculator is telling you now is that the unit should not be less than 23.375. But we cannot use all these values as it is. And as a matter of fact, there are certain values that are ideal when it comes to unit selection. If you move on to numbers up to 20 and above, 20 is a good unit. The next good unit within the range of that 20 is 25. After that, you talk about 30. For numbers to reach that value whenever you are talking about graph plotting, it simply means that definitely the numbers, they have a wide gap. And that, of course, you can see in this column that the values are wide, the gap between them is pretty wide. So when the calculator gave us something like this, then one should think of the approximation to do. You can either round off this 23 to 20, or you round it off to 25. Are you following right? Now, one thing is that if you round it down to 20, this rounding off does not follow our normal principle of rounding off. It doesn't. In selecting your unit, whatever that calculator gives to you, when you do highest value in the column to be plotted, divided by the number of lines available for plot. When you do that, the approximation you carry out does not follow our normal rounding off. Are you following? Where if a number is up to 5, you round up. If it is less than 5, you round down. We don't use that principle here. The principle that is going to guide us here is simple. How can we round off this to get ideal unit, number one, such that it can contain our highest value? Now, I'm going to leave you for the option of either 20 or 25, I've said, because in the range of up to 20 values or something you want to select as unit, you get up to 20 and above. After 20, you should be talking about 25 as good unit. Are you following right? So this 23, see that we reduce it to 20. But if I reduce it to 20, take notes. The last line available for plot, which is this line number 8, cannot show our highest value, 187.5. It can't show it. This 187.5 will go above this 8 line. It will go above this line number 8. And that is the reason why I usually leave, like I said, up to 2 centimeters free. In case whatever I obtain in my calculator while trying to determine the unit requires that I have to round down, that I have to go down below what calculator gave to me, because calculator gave me 23.375. If I take any unit less than this value, following the number of lines available for plot, my highest value in the column to be plotted cannot appear here anymore. It can't. It will go above it. It's only if I use this value exactly, 23.375, that highest value, 187.5. It's only if I use the exact value that calculator gave to me that 187.5 will appear on this line exactly. Because in that case, I'll be using 23.375 on each 2 centimeter. By the way, take note that this graph is into 2 centimeter, which means that here will be 23.375. Here will be to add another 23.375. Here will be to add another 23.375. If you pile up this incremental unit, line number 8, with that exact value calculator gave to us, will contain 187.50 exactly. It will show it. Are you following right? It will show it. But like I said, we can't use that 23.375. It's a bit odd. And I've told you what to do. Either you go for 20 units or you go for what? 25 units. I've told you if you go for 20 units, since you reduce the value calculator gave to you, that highest value in the column to be plotted on the vertical, 187.50, won't appear here. It will go beyond it. But you don't need to be scared. This 2 centimeter line you left will cover it up. And like I said, that's the reason why I prefer leaving up to like 2 centimeter free space whenever I'm counting number of lines available for plot. Now, if you decide to use 25 units, which means you are increasing this value calculator gave to you, I want to increase it to 25. In that case, the highest value available, the highest value to be plotted in the column, right, will come below line number 8. It won't get up to it. You would see that 187.5 somewhere between line number 7 available for plot and line number 8 available for plot. Okay, which means that this line, the value, the unit that will appear there will be greater than that 187.50. And the reason is simple. From what calculator gave to you, you decided to increase the unit. You decided to do what? Increase the unit. I think for this, I'll go for 25. I have my reason for that. There is a particular format I follow. 23 is quite close to 25. 23 is closer to 25 than it is to 20. So I just prefer to go for 25. But if you go for 20, no problem. The choice is yours. Don't worry, I'm going to show you what it would be if you had gone for 20. So here, it means that every 2 centimeter, I'll replace it with 25 units. So this is 25. This will be 50 because you will be increasing it by 25 since you're using that unit. If you do that, this will be 75. This will be 100. This will be 125. This will be 150. Right? And then this will be 175. Whereas this 8 line will be 200. So do you see 187.5 is between 175 and 200. So I'm trying to write it a bit bold so you can see it since I'm using pencil. But I've used pen, but I don't like doing that. Let's go with this. This will be 150. You know, it's best to use pencil so that for any reason, if you need to wipe, you won't have that. You need to erase, you won't have problems. So what I'm doing here is to add 25 units to get the other one. Your starting point will be 25 units. So you keep adding 25. If you add 25 to 175, like I said, this line number 8 available for plot will be 200, you know. And this is very good. You see this calculation I did showing you our highest value in the column to be plotted divided by number of lines available for plot. It's a very cool formula to use for a graph plotting in order to select unit. With that, you don't need to be scared whether your highest value will enter or not, because it will definitely enter. If you had used 20 units, here will be 20, this will be 40, this will be 60, this will be 80, this will be 100, right? This will be 120, this will be 140, this will be 160, this will be 180, and then this will be 200. Although you're not allowed to plot on this marginal. But then you find out that if this is 180, 187.5, which is the highest value in that column to be plotted, would come between this second to the last line and the marginal. All right? But I always prefer to see the last value. I like seeing it covered. But like I said, 23 is closer to 25 than it is to 20. So it is best to go for 25. And I hope you understand this, how I was able to come up with a good unit. We'll do similar to the horizontal axis, which is Li plus LO axis. In the table of value, the Li plus LO axis, right? The highest value there is what? The highest value from what you're seeing is 42.50. So all you have to do is to divide 42.5. You're going to divide it by the number of lines available for plot on that axis. So let us go to our graph using 2 centimeter. Now from this line to this line is 2 centimeter. This is the zero line already because that's the axis we selected on the vertical. How many lines are available for plot? We go 1, 2, 3, 4, 5, 6, 7. Like I said, I would like to leave this line to take care of any plus minus necessary. So there are 7 lines available for plot. And I'm going to divide 42.5 by 7. And this gave 6.07, I would like to use 6 units. All right, 6.07. I would like to use 6. Now, you notice that by using 6, I have reduced this value that calculator gave to me. But hey, don't worry. Don't worry. The last line you left, we cover up for you. Does that make sense, right? We cover up. 6.071 is very close to 6. And in this case, 6 is okay for us to use as it stands based on what we obtained. So, each 2 centimeter will be increased by 6 units. This first line will be 6 units. So I'm going to write 6. This will be 12. Remember, you're increasing it by 6, 6. This will be 18. Right? If you add 6 again, you get 24. Add 6 again, you get 30. If you add 6 again, you're going to get 36. 36. Add 6 again, you get 42. 42. 42. Add 6 again, this line will give you 48. 48. So you see, it covered the highest value in the column we are plotting. It covered it. Because we have 48 here showing in the graph. Whereas in the column of Li plus Lo to be plotted, the highest value there is 42.5. And this is cool. There is no stress in selecting unit. I hope you love this, right? Good. As long as the graph is a normal graph like this, the values you are plotting, they are spaced. They are what? Spaced. You can see there are good spacing between any 2 values. This is the best way of selecting your units so as not to be bothered whether your highest value will enter or not. And so that your graph would also be well spaced, right? The space of the outline of the graph would be, good. Very good, okay? So I want to take note of this. Now that I've selected the unit, the next thing is to start plotting. But before you start plotting, please, you're expected to know the value of each small line, both on the vertical axis and on the horizontal axis. Yes, because most times, the values in our graph, they fall on this. Because most times, the values in our table, right, they fall on all these small lines. So it's important for you to determine the value of each of the small lines. And how do you get the value of each small line?